Hey everybody, in this video we are on example 6 in section 4 of chapter 1 of Algebra 2. This section is quadratic equations on the chapter of equations and inequalities. And example 6, we are focusing on using the quadratic formula to find a non-real complex solution. Well, really define two of them. They come in pairs, Anything with I comes in pairs, like the eyes on your face. Imaginary and irrational solutions come in pairs. All right, so in order to use the quadratic formula, as we all should know, we need to have the equation equal to 0. So I'm immediately going to subtract x and add 4 to both sides. Now I'm going to go ahead and plug all this into the quadratic formula. I went off on a rant in the last video. So if you want to know what annoys me, just go right over there. So x equals negative b. Oh my God, it's not x. It's not x, guys. The b is -1. So negative b is 1. Okay? There should not be x on the right side of the quadratic formula. The only x there should be an x on the left, plus minus the square root of b squared will be 1 minus 4ac. 2 times 4 is 8. 4 times 8 is 32. So that'll be 1 minus 32 under my radical in a moment. All over 2a, which is 2 times 2. X equals 1 plus minus the square root of, we just said it's 1 minus 32, negative 31, all over 4. Then I have a negative in my radical. We should know how to deal with that from section 1.3. 1 plus minus I square root of 31 all over 4. And the square root of 31 does not simplify. It's a prime number. There's no perfect squares in there. And that is 2 non-real complex solutions. They are imaginary. Complex, they're basically a plus minus bi, right? We have 2 imaginary solutions. How can I write it like that? It would be like x equals 1/4 plus minus root 31 over 4. If I looked at it like that, what is A, what is B? You could kind of break it down in that way, okay? So the A, 1/4, and then the B, that's a little bit too bold of a highlighter. What am I doing? The B is root 31 over 4, and then the I right there is right there. And there is your 2 different answers, plus, minus, right? So those are your answers. We have 2 complex A plus BI, A minus BI solutions. I can't simplify anything else. It's perfectly fine to just leave your answer as it's written right there in the box. It's beautiful. It's lovely. We love it. In the next example, we're going to be solving using a polynomial, the sum and difference of 2 squares. And if you remember when we factored those, I repeatedly warned you that the quadratic factor in the sum and difference of cubes when you're factoring is prime, not factorable. So now we're not just going to have expressions, we have equations we're going to be solving. Can't solve it by factoring since it's prime. So we're going to solve it with quadratic formula, and we will, I promise you, a million times over, get imaginary solutions. And I have a special shortcut. It is the Delta Tango shortcut, my YouTube channel. We can name it that. I've never seen it in a book. I'm sure it exists somewhere. I was never taught it. It's just my shortcut. Okay, so I derived it the way we derived the quadratic formula. I derived it myself. Again, I'm sure I did not invent this. Somebody else, I'm sure, did. And it's just somewhere, and they don't put it ever in algebra books. I don't know. All right. Enough yammering. Check the playlist, check the next example, check the description box for the links to the next example. We are section 4, example 6 right now. So you're looking for section 4, example 7. That's it for now. Adios. Oh, thumbs up, please. Please and thank you.